When you do math, what exactly are you doing? Are you inventing something? Discovering something? Or making up rules for a game that happens to be useful? Most people assume math is a human creation. Symbols and operations we invented to count sheep and build bridges. But some of the greatest mathematicians and philosophers in history have believed something far stranger. That mathematical objects exist independently of human minds. That numbers, triangles, and functions are real as mountains and electrons, just in a different way. This view is called Mathematical Platonism, and the argument for it is surprisingly hard to dismiss. Plato believed there were two worlds. The physical world we inhabit, full of imperfect, changing things, and the abstract world of forms, perfect and eternal. A circle you draw is imperfect, but the form of the circle, perfect roundness, exists in a realm beyond space and time. Mathematical Platonism extends this idea. It holds that mathematical entities, numbers, sets, functions, geometric objects, exist as abstract objects. They are not physical. They do not have mass or location. But they are real. They existed before humans. And they would continue to exist if humans vanished. The number 7 was prime before anyone knew it. The Pythagorean theorem was true before Pythagoras. In 1960, physicist Eugene Wigner published an essay with a striking title, The Unreasonable Effectiveness of Mathematics in the Natural Sciences. His observation, mathematics developed for purely abstract reasons, with no physical application in mind, keeps turning out to describe physical reality with uncanny precision. Non-Euclidean geometry, invented as a logical curiosity, became the language of general relativity. Complex numbers, invented to solve equations that should not have solutions, govern quantum mechanics. Group theory, developed as pure algebra, describes the symmetries of subatomic particles. If mathematics is just a human invention, why does it keep predicting nature so perfectly? Wigner called it a miracle. Platonists have a simpler explanation. Math works because it is real. Consider prime numbers. No one decided that 2, 3, 5, 7, 11 would be the primes. Mathematicians exploring numbers found them there. Like geographers discovering mountains. The twin prime conjecture, that there are infinitely many pairs of primes separated by 2, has never been proven, but it is either true or false. The answer is out there, waiting. When Andrew Wiles proved Fermat's last theorem in 1995, after 357 years of attempts, it felt like discovery, not invention. The theorem was always true. Wiles just found the proof. Mathematicians routinely describe their work as exploration of a landscape that exists independently of them. This phenomenology, the lived experience of doing mathematics, strongly suggests there is something to be discovered. The philosopher W.V.O. Quine and mathematician Hilary Putnam gave mathematical Platonism its strongest modern argument, the indispensability argument. The logic runs as follows. Our best scientific theories, physics, chemistry, biology, are our most reliable guides to what exists. These theories are indispensable, and these theories quantify over mathematical objects. Equations use numbers, models use sets, theories use functions. Therefore, if we believe in electrons because physics requires them, we should believe in numbers because physics requires them too. Mathematical objects are just as indispensable to science as unobservable physical entities. So they deserve the same ontological status. Platonism has powerful critics. The most serious challenge is called the epistemological problem, raised by philosopher Paul Benacerraf in 1973. Abstract objects, by definition, are non-spatial and non-causal. They do not interact with physical reality. So how do we know anything about them? If numbers are in a realm beyond space and time, how does our brain, a physical organ, make contact with them? Physical perception works through causal chains. Light hits the eye, signals travel to the brain, but no causal chain connects us to abstract objects. How can there be mathematical knowledge if there is no mechanism for getting it? This is a serious problem. Platonism posits entities we cannot perceive, touch, or causally interact with, yet claims we have reliable knowledge of them. The epistemological challenge has driven philosophers toward alternative views. Nominalism holds that mathematical objects simply do not exist. Numbers are just names, convenient labels we apply to patterns. When we say there are 3 apples, we are not referring to the number 3, just describing a fact about apples. Math is useful fiction. Formalism, associated with David Hilbert, says math is a game played with symbols according to rules. The symbols do not refer to anything. Consistency is all that matters. If the game does not produce contradictions, it is good mathematics. Intuitionism holds that mathematical objects are mental constructions. They exist only insofar as we can construct them. A theorem is true only when proven, not before. Each alternative solves the epistemology problem but creates new puzzles of its own. Platonists have responses to the epistemological challenge. Some argue we have a faculty of mathematical intuition, a kind of rational perception that gives us access to abstract objects. Kurt Gödel himself believed this. He thought humans could perceive mathematical truths directly, through reason. Others argue the epistemological problem applies to all abstract entities, including laws of logic, moral truths, and propositions. If Platonism fails for mathematics, it fails everywhere. But we cannot do without abstract entities entirely. So the problem may be general, not specific to math. Some philosophers bite the bullet. Mathematical knowledge is just different. It is a priori, derived from reason alone, not experience. This does not make it less reliable. It just makes it special. What is really at stake in this debate? If Platonism is true, the universe has a mathematical structure that exists independently of minds, and our ability to discover it is one of the most remarkable facts about human cognition. If nominalism is true, mathematics is a spectacular fiction, incredibly useful, internally consistent, but ultimately not tracking any mind-independent reality. If intuitionism is true, mathematical reality is created by thought, which makes the unreasonable effectiveness of mathematics even more mysterious. Each position has profound implications for what knowledge is, for what reality is, for the relationship between mind and world. Mathematics sits at the intersection of logic, metaphysics, and physics, and what we say about it says something deep about everything. Mathematical Platonism remains one of philosophy's most contested and fascinating debates. The arguments for it are serious. The discovery phenomenology, the indispensability argument, the unreasonable effectiveness. The arguments against it are equally serious. How can we know abstract objects we cannot interact with? No consensus has been reached. The greatest logicians and mathematicians of the 20th century, Frege, Russell, Gödel, Hilbert, Quine, disagreed profoundly. Perhaps what is most striking is that the question is genuinely hard. If mathematics were obviously just a human invention, it would be strange that it works so well. If it were obviously discovered, it would be strange that we cannot explain how we access it. The mystery of mathematics points toward something deep, and still unanswered, about the nature of reality itself.